Alright, our DLO for today is I will learn about slope as a rate of change. So go ahead and write that down for me. And our essential question is we're going to be given a graph and I want to know what is the rate of change of this line. So if I draw this graph, the bottom axis is going to be time, which is in seconds, and I'm going to go ahead and label that time. So if I do so, I have 7 labels over here. So 1, 2, 3, 4, 5, 6, 7. I'm going to label the vertical axis as 5, 10, 15, 20, 25, 30, 35. And that will be a distance. So go ahead and write that down, a distance in feet. So my first point is going to be at 0 seconds and 10 feet. So I'm going to go ahead and write that, put a point there for the red line. And then I'm going to have a vertical line here at 5 seconds and 25 feet. So I'm going to go ahead and connect those 2 points. So those are going to be my 2 points, and I'm going to connect that line. And my question for you guys is, what is the rate of change of this line? And we're going to talk about what rate of change is today, so hopefully at the end of today you guys should be able to answer that question and figure out what rate of change is, or what the rate of change of this line is, I should say. For our vocabulary word today, we have rate of change, because you guys have never heard that before. And another word for rate of change is just slope. So the rate of change is comparing, or the rate of change compares, I should say, two different quantities that are changing. And we usually talk about rate of change when we talk about an x and a y axis with slope. So it's essentially the slope. It's the rise over the run. It's just that because we give specific units to the x and y axis here, the rate of change is a specific quantity or a ratio between two quantities. So go ahead and pause the video to write all this down. Make sure you have all this jotted down, and then we'll go on to the notes section. So like I said up above, the rate of change is the slope. So slope provides an important way of visualizing a rate of change. Slope provides So when we talk about rate of change, we're talking about the way that something's changing with respect to the x and y axis with slope. And it's a nice visual because you put it on a graph and you can see what is the rise, what is the run. So let's look at a few things first of all. So if the rate of change is slope, I want you guys to highlight that because that's kind of important that you understand that concept, that the rate of change is just the slope. So if we look back at our notes on slope from previous notes, we know that m is the variable for slope. We know that the equation is y2 minus y1 over x2 minus x1. Or in other words, it's the change in y over the change in x. So y2 minus y1 gives you the quantity of how much y has changed divided by x2 minus x1 gives you the quantity of how much x has changed. So I want to compare that to the rate of change, because here if we look at rate of change, the rate of change is also the change in y over the change in x. And we're going to look at an example down below. So it's the change in the units on y. Actually, we'll just write this later, so we'll leave that alone for right now. We'll come back to that. Alright, so the rate of change is slope. M equals y2 minus y1 over x2 minus x1, which is the change in y over the change in x. And I want you guys to highlight that. The rate of change is slope because it's important to know that. So here we have an example. So go ahead and write this example down. It says, you are parachuting, and at time equals 0, so at t equals 0 seconds, you open your parachute, and you're at a height of 2,500 feet, all right, above the earth. So what's happening is you're parachuting, you're falling, you decide to open your parachute at 2,500 feet, and we're going to start the time right then, so that's time equals 0 seconds. After 35 seconds, you have glided to a height of 2,115, so 2,115 feet. And it says, what is your rate of change? So the change is the slope, all right? So we want to know what your rate of change is in height. So go ahead and write that down. If you need to pause the video to write that down, that's fine. But I want you guys to have this in your notes. This is the only example we're doing today. So first, I think it's helpful if we draw a graph. So if we draw a graph of the points, we can label our graph. So 5, 10, 15, 20, 25, 30, 35. And then if you notice down here at the bottom, I have this little zigzag on the y-axis. That means that there's a break in the graph, or in other words, it's not evenly spaced. So I jump straight to 2100 from 0. So that's what that means. It's not evenly spaced. So we can label that as 2100, 2300, 25, and 27. So our vertical axis is going to be the height. Now, right now I put h. You'll see later I'm going to actually erase that and put feet because the height is in feet. Our horizontal axis is the time, so it's in t. Notice that I will probably erase that in just a minute as well because we're going to put seconds there. So it says for our first point at t equals 0, so over here at 0, I'm at 2,500 feet. So I put a point here at 0, 2,500. All right, and then if I go a little bit further, I have a point over here at 35 seconds, and then 2,115, so 2,115 feet. So I have 2 points, and I can connect that line. So I'm going to connect it with a straight line. So I have my picture, I have my graph, I have my points, and now I can figure out the rate of change. Because the rate of change is slope, I know that slope is change in y over change in x, or in other words, rise over run. So I can see how much I rose, and I can see how much I ran. So the rate of change would be the change in height, because that's the change in y, because notice that height is on the y-axis, over the change in seconds, or the change in time. So the change in height is you subtract the y-coordinates. So subtract 2,115 minus 2,500, and you get negative 385 feet. So that's the change in y. And then for change in t, you have to subtract the x coordinate. So you subtract 35 minus 0, and you get 35 seconds. And so this is looking at the slope, the change in y over the change in x. But in this case, since we have different variables, we have the change in height over the change in time. And when you divide both of those, you get negative 385 over 35. And when you simplify that in a calculator, you get negative 11 feet per second. So the rate of change is negative 11 feet per second. That's the slope of this line. So change in y over change in x. We could have counted and we could have gotten the same answer, but that's how you do this one. And then last but not least, what does this mean for us? Well, it means that for every second, all right, for every second that you fall 11 feet. So you're going 11 feet down every second. So from point A to point B, from 0 seconds to 35 seconds, every second you fell 11 feet, and that's how you got from a height of 2,500 feet to a height of 2,115 feet. All right, so I know this was a short video today. Make sure you copied everything down, and we'll see you tomorrow.